Hello dear friends, Monday, July 17th, 2023. How you doing? Hope you had a great weekend. I just want to let you know that I'm going to be reading this book this week. It's by Richard Feynman, and it's called The Character of Physical Law, and it's described as the greatest physicist of the 20th century is the description. Richard Feynman. Now, if you remember the last book that I reviewed by Freeman Dyson, this guy worked together with Freeman Dyson. He was born in 1918. He graduated from MIT in 1939. He went to Princeton, received a PhD in 1942. It says he's one of this century's most brilliant theoretical physicists and original thinkers. And this book is a compilation of some of his most famous lectures from around 1960. And so I've read the first chapter. I'm not going to go into a long series of videos on this book because I think it is much too esoteric for the common interest, in my opinion. It's very obscure. But I'm just going to pull out a couple of things from the first chapter I read. And that is from page 27 on the law of gravitation. An example of physical law is the name of the first chapter. And he's talking about the effects of gravitation and the universe. And there are these gaseous nebula. And the gaseous nebula is a gas, right? And he says, he includes a photo here. He says the black specks are places where the gas has been compressed or attracted to itself. Perhaps it starts by some kind of shock waves. He says perhaps it starts by some kind of shock waves. He's talking about the formation of stars. Where do stars come from? The formation of stars. Perhaps it starts by some kind of shock wave. But the remainder of the phenomena is that gravitation pulls the gas closer and closer together so that big mobs of gas and dust collect and form balls. And as they fall still further, the heat generated by falling lights them up and they become stars. And we have some evidence of the creation of new stars in this photograph. He mentions the photograph. So this is how stars are born. When the gas collects together too much by gravitation. Sometimes when they explode, the stars belch out dirt and gases, and the dirt and gases collect back again and make new stars. It sounds like perpetual motion. In other words, they have no clue where stars come from. They don't know where stars come from any more than they know where a flower comes from or where a rabbit comes from. They don't know. They say, well, gravity must cause the gas to compress. And he says, perhaps there's some kind of shock wave there. He hasn't got a clue. And this is from the century's most brilliant theoretical physicist from our generation, well, the previous generation. This is from 1960, so maybe they've made discoveries since then. But I doubt it. They don't know where stars come from. They said maybe they explode and then the gas recollects again and makes new stars. That's just total speculation. 100% total speculation. That's from the first chapter. So I'm certainly not impressed by any new revelations about where stars come from. And one other passage I'm going to share with you. He says, finally, in connection with the laws of physics on a small scale, we have found that the behavior of matter on a small scale obeys laws very different from things on a large scale. So the question is, how does gravity look on a small scale? That is called the quantum theory of gravity. There is no quantum theory of gravity today. People have not succeeded completely in making a theory which is consistent with the uncertainty principles and the quantum mechanical principles. So they don't know how things behave on a very small scale as opposed to things on a very large scale. The laws don't apply from one to the other. And it's still, to this day, they don't know why it's different. I'm going to mention something that I observed a long time ago that I never had an answer for intuitively. If you look at an avalanche, for example, or the example I used was the difference between an actual automobile, if you see it traveling through and it crashes. Let's say you're watching a car race, or you're watching a movie and a car hits a barrier and flips over. It seems to move a little slower. It's flipping and you see it flipping and boom. You take a little toy car that you have when you're a kid and you throw it and you fling it and it just goes instantly, right? It seems to go so fast. But the larger it is, You see a large building imploding. It seems to move slowly. You take a tiny little building of Legos and a Jenga, you hit it and it just collapses instantly, right? And so the time difference from large objects to smaller objects, obviously there needs more time for greater distance. You look at an avalanche and you see the snow coming down the mountain and it looks to be moving slowly, but it's actually moving extremely fast. This perception of time and distance in relation to size is different from the large things. Einstein said that the faster you go in space, time slows down. And so these avalanche of snow that's coming down the mountain is actually moving very fast, but the time perception is slowed down. And as he mentions in his book on page 32, 33, there's no explanation of that yet. We don't understand why things behave differently and time behaves differently depending on the scale that you're dealing with. So I just thought I'd mention that. That's from chapter 1. Like I said, I'm not going to make a whole bunch of videos on this book because it's something that a physicist or an astronomer might be interested in, but it's not really my thing. Unless something really jumps out at me, then of course I'll try and share it with you. But you know, it's got all these diagrams and formulas and all this thought experiments and stuff, and so I think it's going to be a bit of a slog, a difficult read. I'm not really looking forward to it. It's nowhere near the readability of the book by Freeman Dyson. This is just a series of lectures, very dry and very boring. So the next chapter called The Relation of Mathematics to Physics. How interesting that's going to be, right? But I'll try and get through it. I'm also reading at the same time a book that was sent to me. It's online. I don't have a physical copy of it, but he sent me a link to it, and that's called Rational Recovery. And what it is a book about how to break free from addictions, whether it's alcohol addiction or drug addiction or food addiction, whatever kind of addiction you have. And it's a replacement for Alcoholics Anonymous. At one time, Alcoholics Anonymous was the only treatment program that was available for people that were addicted to alcohol. And now he has this new program that he calls, it's about, I don't know, 15, 20 years old, that's called Rational Recovery. And it uses the principles of AVRT, Addictive Voice Recognition Technique, where you recognize when you're telling yourself that you're an addict, or you're telling yourself you have a disease, you're telling yourself you're an alcoholic, and to recognize that voice and to defeat it. He calls that voice the beast. And the strategy to defeat that by replacing those statements with statements of positive affirmation, right? I can quit. I can take control of what I put into my body, and so on and so forth. So I'm reading that at the same time, and that's very good. It's a short read, so I'll probably get through that this week as well. But anyway, I just thought I'd keep you up to date on what's going on out here in Nirvana, out here in El Marais, Ontario, the land of milk and honey. I hope you're enjoying wherever you are, wherever you live, that you're in a beautiful place. It's summertime here, so it's beautiful in the summer. Of course, I wouldn't be saying that in the wintertime. So wherever you are, I pray that you're blessed, that you're happy, that you're enjoying good weather, that you're able to spend time with people you love, and that you're getting some nice contact with nature and fresh air. So God bless you. I love you very much. I hope you're doing well, and we'll talk to you again soon, okay? Take care of yourself. I don't know when my next video will be. It might be later in the week, but I'm probably going to slow down with the videos because I was doing one every day for a while. And unless I get some really new, exciting info for you, I'll just leave it at that. So hope you do well. Enjoy your summer. We'll talk to you soon, okay? Take care. Bye-bye now.